Okay, so I did problem 7.3.50, which reads in exercise 47 through 50, the integral represents the volume of a solid of revolution. Identify A, the plane region that is revolved, and B, the axis of revolution. So my equation was V equals 2 pi times 4 minus x raised e raised x dx integrated between 1 and 0. So seeing this, I see the 2 pi, as well as the fact that 7.3 is the shell method. Therefore, I know that this pertains to the shell method. And the volume for a cylinder, which is used in the shell method, is 2 pi RH. So looking at the equation, I can tell that the radius is 4 minus x, and the height is e raised x, because that's what makes sense. So I already have my region bounded pretty quickly, because knowing that the height is e raised x, that means it has to be bounded by the x-axis, because e raised x is always positive. So therefore I came up with my region of rotation, which is bounded by x equals 0, x equals 1, e raised x, and y equals 0. And over here I drew my representative rectangle, and I know that it's, first of all, I know it's dx, so that's where the slimmer end of the rectangle would go. And I also know that because it's shell method, the representative rectangle will be parallel with the axis of rotation. And because I figured out my h, it's pretty clear that my r is 4 minus x. So in order to get this r, there has to be an axis of rotation at 4, and x is the distance from the y-axis. And so that's how you get, so 4 minus x would get the distance from your representative rectangle to the axis of rotation, which is 4 minus x. And because of that, and I depict over here, so the radius is 4 minus x, dx is the width, and the height, even though you probably can't see it, is e raised x, and that's the slope that it's on. So I find my axis of rotation to be x equals 4, and that solves for A and B.